Hello everyone. Thank you for making time in your busy schedule. My name is Taiga Mori and I'm a first year master's student at Chiba University and research assistant at AI Research Center ICE Tokyo Waterfront. Today, I'd like to talk about the analysis of body behaviors in human-to-human and human-to-robot interactions. My presentation consists of 7 parts. First, I'd like to talk about the introduction. Second, data. Third, hand gestures. Fourth, head gestures. Fifth, body gestures. Sixth, summary, and finally future works. Recently, many researches have been conducted on multimodal interaction to widen our understanding of human behavior and interaction. Novel technologies such as video, motion capture, eye tracker, and sensor devices provide accurate data for big data and machine learning. Moreover, recently more dialogue-oriented interactive systems have been developed, and it is important to study multimodal communication in situations with humans and other interactive agents. Although many researches have been conducted on speech-based human-to-robot interaction, there are still few researches on multimodal signals in human-to-robot interaction. This study is preliminary analysis on hand, head, and body gestures in human-to-human interaction and human-to-robot interaction. We focus on the difference between human-to-human interaction and human-to-robot interaction, and also compare Japanese interaction and English interaction. The data is from the ICO corpus. This corpus has 60 conversations and consists of 30 participants, 20 native Japanese and 10 English speakers with backgrounds in Europe, US, and Southeast Asia, and they had 2 sessions, one with a human partner and one with a robot partner, for about 10 minutes respectively. The data was collected using video camera, Kinect, eye tracker, and a questionnaire about impression on the robot. Gestures were annotated based on MUMI annotation schema. 60 conversations were used for the following analysis. First, I'd like to talk about hand gestures. In accord with our expectation, English speakers produced 6 times more hand gestures than Japanese in human-to-human. But their difference is not big in human-to-robot because both speakers produced only self-directed gestures such as touching a table or scratching one's body in human-to-robot. This implies that they didn't use hand gestures for interaction to the robot, and it is necessary to focus first on eliciting gestures from the user rather than on recognizing gestures. Next, I'll talk about hand gesture form. Although curled fingers was most frequent in both human-to-human and human-to-robot, more various forms were observed in human-to-human than in human-to-robot. In our schema, curled fingers is defined as the default form realized without any effort. That is, participants made more complex hand forms in human-to-human. Considering the language differences, English speakers produced twice more gestures than Japanese in almost all forms. This suggests that robots have to recognize more various hand gesture forms in English than in Japanese. Next, I'll talk about hand gesture function. As with the form, more various functions were observed in human-to-human than in human-to-robot. Considering the language differences, English speakers produced more rhythmic gestures than Japanese.
I measure the biosignals.
This suggests that prosodic information such as intonation or rhythm might be more important in English than in Japanese. Moreover, Japanese produced fewer emphasis gestures than English speakers. This implies that Japanese might emphasize important points in other modalities. Next, I'll talk about hand gesture trajectory. Trajectories were classified into 4 types. Straight trajectory means moving up, down, or sideways. Complex trajectory means complex directions. Static means staying in the same position and location. Touch is like static, but keep in touch. Straight trajectory was most frequent and about twice as much as complex one in human to human. But complex trajectory was not observed at all in human to robot. This result is consistent with the fact that participants produced few complex forms in human to robot. Complex trajectories and forms could represent more rich information visually, but they would demand more cognitive cost in terms of production, recognition, and interpretation. Therefore, participants seemed to save the cost because they didn't regard the robot as a partner who can recognize rich information. This indicates that in order to elicit hand gestures from humans in human-to-robot interaction, the robot should be perceived by humans that it can interact with them tactfully in visual modality. Next, I'll talk about handedness. Based on the results of form and trajectory, it can be predicted that both hand gestures would be less than single hand gestures because they would be more costly. However, their difference was not so big either in human to human nor in human to robot. This suggests that both hand gestures cannot be omitted into single hand gestures because they are determined by their function and the content of the gesture expression. Next, I'll talk about hand gesture repetition. Similarly to the handedness, the difference between single and repeated gestures was not big either in human to human nor in human to robot. While single gestures were frequently observed in emphasis gestures, repeated gestures were frequently observed in rhythmic gestures. Next, I'll talk about head gestures. As with the hand gestures, head gestures remarkably decreased in human to robot. But as contrasted with hand gestures, the difference between English speakers and Japanese was very small. In fact, Japanese produced slightly more head gestures than English speakers in human to robot. Next, I'll talk about head gesture form. Nose gestures were remarkably most frequent in human to human, although Maynard 1989 showed that native Japanese speakers tend to nod more frequently than American English speakers. There was no big difference between Japanese and English in human to human. This is because perhaps not all English participants were native speakers. But Japanese produced slightly more nod gestures than English speakers in human to robot. It seems that Japanese behaved with the robot in the same way as they always do with the human partner. Next, I'll talk about head gesture function. Acknowledge and emphasis gestures were relatively more frequent than other functions in human to human. On the other hand, in human to robot, acknowledge and adapter gestures were relatively more frequent than other functions. Concerning to the language differences, Japanese produced more acknowledged gestures than English speakers in human to robot, because Japanese nodded not only during human speaking but also when the robot speaking.
みたいなら、僕と話したいのであれば。
Moreover, Japanese produced more emphasis gestures than English speakers in human to robot. This result suggests that Japanese used mainly head gestures for emphasis rather than hand gestures. Next, I'll talk about head gesture repetition. While repeated gestures were more frequent than single gestures in human to human, single gestures were more frequent than repeated gestures in human to robot. Although repeated gestures would involve more physical cost than single ones, they also enable us to represent strong empathy or deep understanding to a speaker. It seems that participants intended to give strong encouraging feedback to the partner in human to human, but saves the cost when talking to the robot. Next, I'll talk about body gestures. While hand and head gestures decreased in human to robot, body gestures remarkably increased in human to robot. This result suggests that it is more necessary for robots to recognize body gestures than hand and head gestures. Concerning to the language differences, English speakers produced more body gestures than Japanese. Next, I'll talk about body gesture form. Forms were classified into three types. Forward means leaning toward the partner. Backward means leaning away from the partner, and other means other forms. Forward movements were most frequent in human-to-robot. For instance, participants leaned toward the robot when they spoke to the robot. They sometimes spoke to the robot in the middle of its utterance, even though it was programmed to light up and sound on the end of its tongue. This implies that they couldn't use such unnatural cues for turn-taking. On the other hand, backward movements were observed when the robot failed to catch participant words. After that, they returned to the original position in order to restart the conversation. These behaviors may imply that they made interactive formation with the robot like an F formation. Next, I'll talk about body gesture function. Better contact was most frequent in human-to-robot because participants were able to regulate appropriate distance each other in human-to-human. However, they had to do that by oneself in human-to-robot, and which involves cost for humans. Therefore, it is desirable for robots in the future to recognize and regulate appropriate distance to humans. Moreover, although frequency of adapter gestures was not so different between human-to-human and human-to-robot, their movements were different. While participants changed their body posture or touching one's body when nervous in human-to-human, they shook their legs in frustration to the robot's failure in human-to-robot. Next, I'll talk about body gesture repetition. Single gestures were most frequent in both human-to-human and human-to-robot. Single and repeated gestures were observed as different movements. Single gestures were observed when participants leaned forward with each utterance to speak to the robot, or they changed their body posture. Repeated gestures were observed as swaying body with rhythmic hand gestures or shaking legs from stress. Static gestures were observed when participants continued a head-forward posture for a few seconds. Summarizing the above, first, robots have to recognize more various hand gesture forms and functions in English than in Japanese, but elicit gestures from humans before that. Second, it is important that robots recognize head gestures, especially in Japanese, because Japanese more depend on head gestures than hand gestures. Third, body gestures have involved transmission of information rather than the content of the interaction, and reflect humans' mental state. Finally, I'll talk about our future works. We first aim to finish annotation for statistical analysis. Next step is to study time correlation between gesture and speech. In particular, we are interested in the correlation between speech and head gestures because this preliminary analysis showed that head gestures are relatively important than other gestures in Japanese. Our goal is to investigate how auditive and visual modalities are used as communicative signals, and how to learn interaction models for natural human-to-robot interaction. Moreover, we plan to compare the results to other corpora, because it will be useful to compare various interactive situations and extract features that enable us to generalize over situations. I'd like to close my presentation. Thank you for listening. If you have any questions, please feel free to contact us.